Hey, welcome everybody. So I'm Dave Ward, I'm the CTO of engineering, and this is my good friend Bart van de Velde. And Scott might have told you about some cool stuff, but we're going to tell you about all the cool shit. And really what we want to discuss today is everything you're going to see coming out of the portfolio and movements in the industry around SDN, NFV, orchestration, and how that all ties together. And most of this, if not all of this, you can see up in the DevNet zone or to the right-hand side in a lot of those demo booths. So the slide that I'm showing to you now, I've actually been using, if you've been coming to Cisco Lives for the last few years, I've actually been using this slide for 5 years. And the good news is that we're just about not having to use it anymore. And the reason being is that we're to the point now where service orchestration is not in an open source, it's in product and it can be deployed. The networking piece, including virtual networking, is now in open source as well as in product and can be deployed. And the analytics piece, creating reactive networking, where what you provision into the network, what the network is doing, collection of that data, we can program in this full wheel. And so it's a great time. It's been a ton of work. There's been a lot of discussion in the trade rags, but these platforms are now available. And so towards this end, the trajectory we're on isn't just infrastructure for infrastructure's sake, but is to get to the point where we're working within the PaaS layer, platform as a service layer, where networking services can be directly called from out of the cloud as an application developer. Because today, an application developer can request CPU, RAM, storage, but they can't even request any bandwidth. They can't specify the topology of their workload. That is the target that we're going after. And so towards this end, I just want to walk you through real quickly what Bart, who's just chilling out over here for a second, is going to show us in demo in just a minute. So first, starting at the application, you can go up and see Simon Sprague's and see virtual branch automation. And this is also what you're going to see in the demo, but really what we're talking about here is the ability to not only have virtual network functions in the cloud, but also orchestrate them directly in the branch and on the edge, depending on the topology that you want to deploy. And being able to automate this directly from the same system that's operating in the cloud. The user experience is fundamentally different. We're going to walk you through a number of different roles of everything from somebody ordering a service to operating that service to then also a technician in the field as, again, the state of the art has really moved forward. And in particular, go up and see John and go up and see Nick about the platform for network data analytics, because this is going to end up to be the second 50% of what SDN is really bringing to the industry. Almost everybody continues to talk that you can configure, provision, and program a network. That in itself is an awesome, awesome thing, but the network is now pushing data out via telemetry and via a number of other protocols into data lakes that then have direct access back to that controller to be able to, again, create that reactive network. This architecture that John and Nick and Trevor can show you upstairs is built out of open source pieces. And you saw a description of a number of these pieces earlier today in Beery's keynote. What's interesting is that most of you that I've visited and many, many of my industrial partners also have the slides that list out a number of these projects. There's Apache Spark, there's Impala, there's Logstash. All of these are building blocks. The challenge is that they need to be integrated together into a system that can function and function properly. So what you end up seeing coming out of this are all these pieces integrated together, and to move the industry forward, we're going to be open sourcing this project as well as our next step. From this, and what we're going to show you in the demos, are the advanced analytics that you get not only coming from the network, but also out of the cloud and those virtualized network functions that have been orchestrated and associated with those customers. Additionally, there's been a lot of work that we've done over the last couple of years on routing analytics. The state of the art in the past was taking a look at things like Planet Labs and route views to be able to understand the topology and what the interdomain topology looks like of the internet. This has been fundamentally changed by the introduction of a couple of protocols and a couple of extensions to be able to get the entire topology before policy has been applied to fully understand the complete topology of the routing system, IP and MPLS, that's been flooded or been passed around in the protocols. This also has been open sourced completely. And what you're seeing coming out of quite a bit of routing analytics research, and you're seeing coming out of CIDA, for example, in Southern California, is the industry gelling on BGP monitoring protocol, as well as the scale-out data platform that I mentioned, and being able to write new applications to understand the IP/MPLS topology and interdomain routing. So a couple of screenshots of what this user interface looks like. You know, from one single monitoring protocol session in an autonomous system, you can see all of the peers, and in this case, 405 peers that are hanging off of that. And you can dial in to also see a specific peer view. And then, again, this has been open sourced, and you can see this such that you can dial in to understand exactly what has been sent from each peer, what you're sending to each peer, and then go into oscillation metrics as well as route flat damping, et cetera, and use it to not only find anomalies in the network, but also to be able to find the best path and derive the best policy for your network. Using this data, we're taking a step forward, and we're looking at application engineered routing, also known as segment routing, and Clarence Fiesvis has a talk Thursday afternoon, in depth on this technology. In IP/MPLS, this is probably the most important change that we've seen in a long time. And I've been involved in routing protocols for a couple of decades. You know, gray hair didn't come for free. But what's interesting about what Clarence and the team are doing is we are actually taking protocols out of the network, such that you can directly program from a controller the LSPs, VPNs, and traffic engineered tunnels that you want in the network without using RSVP and LDP, as well as achieving loop-free alternates and avoiding microloops as well. So SDN doesn't just turn into, hey, let's program some data center top of rack switches, and hey, that's all great. It's important work. I'm not trying to belittle it, but for the service providers and for the folks who are into core networks, being able to use a controller to optimize the paths across the network and to be able to pre-program the heads of those tunnels is very, very key, and that's what segment routing brings. Guaranteed all the features of traffic engineering, loop-free alternates for fast reroute, and microloop avoidance, and this is the first technology that does not have microloop problems. It enables you to see the entire network, to be able to rebalance traffic across that network on demand. It becomes a call admission control to an IP/MPLS WAN. And so on the left-hand side, you can see that you can actually place more traffic onto the network, increasing the utilization of the network. And you can also avoid congestion on the network by instantaneously rebalancing that traffic. It's like soft PVCs for MPLS, and it also works over IPv6. In addition, if you go up and see Greg Shepard, and you go up and see a couple of other folks, you're going to see beer. And really what we're talking about here is the ability to program from a controller a replication tree directly into the network. We're taking out PIM. All of that state required to do joins into PIM to create replication trees, RSVP, all of the refresh that we've had to do in the past as network engineers, we're actively removing those protocols by using the controller to program the LSPs or program those replication trees, and it's fundamentally changing the way that we build networks. And in addition, you can directly program traffic engineered load-placed replication trees as well for things like TV channel content creation. Taking a look at the orchestration platform, this has significantly matured, and Bart's going to show you a lot of this in just a second. Remember, the key things of having an orchestration platform is that not only do you have an understanding of the physical topology and virtual topology, which has been talked to death in the trade rags, but you also have the ability to now see the service chain and service view and the policy that's been used to create and place those virtualized network functions. So in reality, what we've done with the architecture is we've expanded it to understand all of the different views and roles that you need to be able to understand and identify the relationship between the resources in the network, including the data center, linking those to the WAN, linking those to the edge, and the access network. And this, the orchestration system can orchestrate that end to end. And so when you take another look at this, realize that what's built into this is an SDN controller as a piece of infrastructure, is the ability to have lifecycle management around the virtual machines, and then overall, via NSO, and our TLF friends be able to see and orchestrate the entire service of virtualized network functions not only in the data center, but also link those to the VPN and residential endpoints. So when we get to the network, what happened last week, I really need everybody to pay attention to. There's a new open source project called Fast Data, or FIDO, which is focusing straight on big banging virtual networking. It is the world's fastest and most scalable L2, L3, MPLS, and all of the critical features necessary in the network on the data plane, not only as a virtualized network function, which has been widely deployed, but also working directly in a container and hypervisor network. So when you take a look at what Cisco open sourced through fd.io or FIDO, you can see, just quickly scanning these features, it is a fully featured superset of what has been needed in the network that's currently only available in fits and starts in an architecture like OVS, which is a monolithic architecture focused on L2. And what we built into this, because we've got decades, obviously, just like you have experience of building and deploying networks, counters for everything, spewing the telemetry out the top to those analytics data lakes, and being able to program all of the critical features necessary day one. And so we're trying to build a community around this, and we have a number of ecosystem partners, and I highly recommend people take a look at that. But to show you the reason why, when you take a look at the orange graphs, that's VPP using DPDK compared to OVS using DPDK, when you start adding MAC addresses, and then also when you, and I'll show you in the next slide, what happens when you add V4 addresses. The main point, constant, consistent performance regardless of scale of those forwarding tables. So when you see that, and you're adding, like a router, when you're thinking about trying to add routing interfaces, et cetera, we know from history that usually the larger the size tables, the more inefficient or slower that table lookup is. And in this particular implementation of VPP, that in fact has no performance degradation. It has no performance degradation for counters. It has no performance degradation for insertion of routing updates, ACLs, MAC addresses, et cetera. And it's a modular architecture that allows features to be added and subtracted on the fly. We've got an application that you can see on top of Open Daylight, and you can go over and visit the team there on being able to build, for example, bridge domains. VPP is supported under Open Daylight as an equivalent forwarder as well. And that's what that application is. So when I put these pieces together, we've linked together the resources of compute, networking, and physical infrastructure with a cloud platform. Right now, based on OpenStack, we are working towards adding the container support, and we've got, you can actually see demos of that over on the other side in the demo area. Getting to the virtual lifecycle management, you can see with the vBranch, and I'll show you in a second. And then get all the way to the point where we are building these pieces into the platform layer for developers to use. So what I want to walk you through, and Bart's going to show us, remain calm, Bart, get ready. Bart, don't fuck it up. We're going to walk through this wheel again, but we're going to walk through this wheel through a number of different roles that a service provider customer or service provider themselves has to work through. So first we're going to take a look at walk through a demo in which you're an enterprise customer buying a service from a service provider and want to add in the ability to have a site added to the network on demand, go through an operator, look at what a product manager view would look like, and that field technician. So Bart, let's go for it.
Okay, let's give it a go.
So the first one we're going to take a look at is where we want to buy a VPN service. So we're an end customer of a provider. We buy the service and we see that we want to be able to configure the controller in the cloud to be able to connect our sites together. So Bart, let's hit the setup. Let's do a bit of static addressing because we want to have our own domain. We then want to be able to add some application QoS and service-based QoS. So what Bart is able to do is drag and drop different applications and type of service as we want that to be represented. Let's keep going, Bart. From there, what we want to be able to do is what type of VPN topology. This is IVPN, where you can do any-to-any connectivity for L2 bridge domains or layer 3 VPNs site to site and not have to create only a hub and spoke design in and out of the cloud. And you can do both. So from there, we're going to set up that controller, whether we can do it hosted in the telco or self-hosted. Bart's going to self-host it here in Berlin. And what we're going to see as Bart clicks through this is that we do have the ability to begin to start to control our network. We want to be able to set up the addressing. We need to enter the serial number of that controller. We're going to validate it. Hey, Bart, let's take a look at the advanced settings for a second. And what we can see here is that there are, in fact, different versions of that controller that you can choose from that have different capabilities built into them, and some have services deployed. So let's keep going, Bart.
Sure.
So from there, when we take a look at what that bill ends up looking for the end customer, you can see that it comes out to a specific dollar amount to be able to connect these sites together. So let's keep going, Bart. We're going to submit that into the system. That's actually spinning up in the background. And from there, we're now going to start adding some sites to the VPN that we just acquired from that telco. And so when we're now moving forward a couple steps where we've already got some sites deployed, and we want to be able to add and take a look at this system. And you can see, keep scrolling down for a sec, Bart, that in fact we can understand the resources we're currently using. We can see the inventory of virtual appliances as well. And then from there, you want to add a site, Bart?
We're going to have a look at Cologne first. That's already there.
So let's take a look at Cologne, and we want to understand the services deployed. We can see the resources we're using in Cologne down below. This is giving us CPU, storage, I/O. We can see some trouble tickets that, or just the history of what's been going on inside Cologne. And as we zoom out,
we can create a new site.
You want to do a new site now? Let's do that now. And let's add one in Berlin.
Yes.
So we're going to take the VPN that we originally acquired from the service provider. We now want to add a CPE to a new site here in Berlin. And we're going to do that, and we realize that out of these sites, there's some basic functionality as well as some configured services based on top. In this case, adding a firewall. We've got our WAN addressing that we want to be able to put into the server to be able to backhaul it. And then from here, we can choose exactly how we want to be able to deploy this. And so Bart, why don't you click through? And what we have the ability to see is the amount of resources that each of these are going to take in the environment in which we selected. And so just pause here for a second. In a new deployment, you can deploy in the existing clouds you are, or as you can see on this screen, you can actually deploy into the public clouds as well. But Bart, let's do it into an existing deployment. And we can see the amount of resources this is going to take. Let's hit go.
We'll do it in Europe.
And so from there, we get our bill of what this is going to take from a NFV point of view and how this is going to work.
Okay.
Let's hit submit. And so from here, we can see the topology. We're going to start spinning this up in the background. You saw that orange go to green. That spin up, and you get back to the top. And you can see that the entire service chain was spun up in that amount of time. And this is done by having a pool of pre-allocated resources available in the cloud to then allocate directly for customers. You want to take a look at templates?
Yes, I do.
So when we go and build this, realize that in the case you may want to be able to have very specific sites or branches associated with different functionalities. Some are retail, some are administration, some are campus, as the case might be. And what Bart's clicking through are the different configurations and the ability to actually go in and modify those templates for each of those sites.
So we'll duplicate one, and then we'll start editing.
Let's edit.
Yeah.
So in this particular case, we're going to grab this one. We duplicated it. We want to modify that service a bit. We're adding a web filtering based upon the different, again, services that are available for that particular web filtering piece. We can add some additional VNFs as well.
We'll add a wireless LAN controller.
Scroll up so we can see that there. So what Bart did when he clicked on that particular piece, a wireless LAN controller was automatically spun up associated with this VPN to be able to manage that Wi-Fi domain directly out of the cloud as well.
Okay. So I think we can put this in the catalog.
All right. So when it's put in the catalog, that means we can reuse it again. And so that appears, and we can collect and go and associate that automatically with any of the branches we previously deployed or with the ones that we want to be able to deploy into the future. So from here, let's zoom out, and now I want you to understand that we're going to take on the role of someone who's trying to operate their network, perhaps the enterprise IT professional who needs to be able to see and understand what's going on in their branches across the globe. We can see that we've got a problem in this particular case in California. Oh, it's up in San Francisco, and it looks like it's on Mission Street. So from there, we take a look at it and we say, wait a minute, it looks like something has been knocked out. And it looks like the CSR is having a particular issue, and it looks like it's down. Again, we've identified which VNF is having particular problems. Let's take a look at it a little bit further and see what's causing it to be down. So what it's doing is it's going into the cloud and taking that relationship between the physical resources of compute and the identifiers of the physical layer, the virtual layer, the service layer, and being able to represent those and visualize those by just rearranging the visualization of the same data in a different way. So we see that the CSR was having an issue. So Bart's going to drag those active VNFs to understand that specific topology, and we can see the problem is on that computer. And Bart, let's clear that out. And when we take a look at that incident itself, we can see the full history associated with the logs because we have that analytics platform running a natural language processing algorithm that links those events together. So when we do this, what happens if there was other customers on that particular computer? Who else was affected? So Bart dragged that over and dropped it on the tile. We re-rendered this again, and now we have a view from the resource of the computer of what other customers had VNFs on that computer itself. This is all the same data in the database, but because we've kept inventory and relationship across all of it from the service layer all the way down to the physical layer, we can rearrange it and re-render that data in any way that we want. So what we're taking a look now was, because we cleared the problem, we're taking a look at a history of what was going on with these customers. And what Bart's scrolling over on the top are events that we correlated together or activities that occurred. So Bart, we're in the problem state now.
Yes.
Let's see the future state, because we cleared it out, and so everything's going to come up green. But because we have that analytics platform going in the background, constantly pulling in telemetry data and events and logs, we actually can predict into the future where there could be a problem and give an operator hints of what they might want to do, what they might want to fix before it happens. And in this particular case, we're predicting that, in fact, there's probably going to be a problem in an hour or so in which a number of customers are going to be affected because we're taking a look at issues with hard drives, issues with computers, issues with interfaces in the network, with virtual machines. In this particular case, that computer is probably pretty flaky, and we need to migrate those customers somewhere else. Now, we went through this quickly, but understand that being able to track from virtual machines all the way down to the resources and where they move inside the data center is a very, very hard problem. Without a doubt, Bart, we learned it the hard way. It's really easy to spin up a virtual machine. It's really hard to know where it went as things start to move in a data center.
Do you want to see the scars, Dave?
Yeah, exactly. So, so let's take one step forward, Bart.
Yes.
And so in this particular case, Jedi mind trick, we're now the service provider product manager. And we want to be able to understand the new products that we want to deploy out of the cloud and understand whether or not the service orchestration in the system is prepared to accept those products. So what we're seeing here across the top is an understanding of delivery, the birth certificate, and the deployment status of those particular services. And so let's take a look at what in jeopardy. And really what this means when we take a look at it is the service is in jeopardy of not being deployed within a service level agreement. And what that means is, so if you're going to sign a service level agreement, that a service could be up and running within 2 hours or 2 days, depending upon whether or not they're getting a CPE, this is in jeopardy. And we can see automatically the services that are required to happen in the service orchestrator to enable this service. And so we can see that there's a VPN in orange on top, and then there's the physical CPE on the bottom. And so really we want to be able to understand whether or not, go ahead Bart, click it, understand whether or not that service is ready to go. So the next thing we want to be able to do is bring up a new service model to be able to be sold as a product. So let's do that, Bart.
Yeah, we just created a new product.
And let's just call it Demo 1. And we realize that, okay, there's a couple of big flows that have to happen. On the top, we've got the VPN services and virtual machines. On the bottom piece, we've got the box itself. And we've got a total amount of time, and we want to know whether or not this has been constructed into a service model that can be deployed. So when you go forward and do this, hey, we can see all the different elements that are ready to go. In that particular case, the device isn't there. So the service actually can be handled in the system.
So now we're seeing if we can move box forward?
Correct. And we move the box forward, and we are ready to go with that service and have it deployed directly out to customers. Again, we ended up learning this one the hard way, that the product managers defining the NFV service and the VPN service, whether vBranch or directly out of the cloud, have to be able to have assurance that they can deliver and deploy these services. So now let's take a look at one, whether or not the service is ready to be deployed, and let's give it some tests. So it's Demo 2, Bart's got it up and running. And so what we want to be able to do is fake the system into believing that a customer has triggered the deployment of this, and then we can do a triggered OAM of the entire path and watch packets flow through this and watch this work. And we can see we've got an issue.
Oh. Run it again.
Yep. Let's run that triggered OAM again and run and redeploy that service as if it was a customer hitting it, and hopefully that service clears. We trigger the OAM, and it should go forward, and it does. And so we're testing it out now with triggered OAM. Sounds obvious, sounds basic, but these tools that we ended up building out for the product managers help us be able to understand the entire state of the service to be delivered to the end customers. Now, the last one that we want to show is a relatively tricky problem. And anyone who's operated a network and these types of services realizes that customers frequently do a change of a request before the first request has been fulfilled. I could want to buy another device. I could want to add another VPN site. And if you've deployed an operational system and a billing system, it's a metric pain to try and be able to handle change orders in the middle of it. And so what we can be able to see here, because it's a model-driven orchestration system on top of NSO, that in fact we can change the state automatically and incorporate, as you can see, Bart added that second chain and flow to it, that we can handle the change order in a model-driven OSS. Model-driven for us is really dependent upon using a data model based in a Yang modeling language. I talked about this last year. We've got programmatic interfaces to the physical and virtual devices in NetConf Yang. We store everything in the database in Yang so we can re-render it in any protocol like OpenFlow or Path Computation Element or whatever the case might be. And even the top of NSO renders in Yang such that we can have a model-driven service in addition to a model-driven network. Next Jedi mind trick. We're going to go over to the field technician.
Do you like my background, Dave?
I do like that background a lot, Bart. So as a technician, what's interesting is that, for example, in a cable provider, between the CMTS and all the residences in the cable modem, CMTS generally handles between 16,000 to 64,000 different homes or businesses, and you effectively have a spectrum analyzer of an entire metro area between the CMTS and the cable modems. You have the same thing between the DSLAM and the DSL modems as well. So we're now, as the role of the technician in the field, and what Bart just showed you before is the map that they have for their daily work. Hey, there's a big problem and it's potentially causing an outage across this area. And so what we've done in this case is we've integrated Spark because the field technician might not be able to figure out exactly what to do or have access to all the data. So we incorporated the collaboration system, and Bart's going to send a note, hey, what the heck's going on here? What possibly could I do to remedy this? Gets a reply back, hey, check the equalization in this particular network. Good to go. All right then, it's part of the recommended fix. They go in and do the recommended fix by using the Data Lake Networks Analytics platform associated with networking data. Field techs themselves can have access to that data by integrating collaboration. They then can work back with the recommended, via other technicians or other levels of tech to be able to go in and find out what the problem was. So we made it from the enterprise consumer wanting to request a VPN, bringing up extra sites. We added the operational view of what's going on my network and being able to dial in and understand between the virtual network machines all the way down to the physical pieces of that, again, by using the big reactive loop between the application and the portal interface through the SDWAN controller orchestration system, the network itself, back up to the analytics data lake, and create a reactive network out of it by all 4 of those roles. We good, Bart?
Good summary.
Not bad. So from here, next Jedi mind trick. So what I want to do is I want to introduce another colleague of ours, one of the greatest superstar coders that we brought onto the team, Alina. Wave to the crowd, Alina. There you go. So, so on this one, I've got a whole new topic for you. Big Jedi mind trick. What I want to describe to you is the ability to use network variables associated to access to electronic assets to be able to decrypt or have access to specific files. So this is software-defined asset security. And what's different about this scheme than any other system that's ever been built is that in the past, for example, if you used Adobe DRM or Microsoft DRM, everybody had to play that game in the enterprise. And anybody who wanted to transfer data to had to play that same game at the application layer. Well, Alina stepped back and said, wait a minute, we know the identity of folks when they log onto the network or onto the SP. We know the machine because we use DHCP. We know what network they're on because they're either on Wi-Fi SSID or they come in a VPN. We also know the GPS that's potentially associated with the phone or with a tablet. And we also know the application that's on board. So what if we took all of those multiple variables and used them and weight them such that does somebody have access to those electronic assets? A Word file, a legal document, source code, whatever the case might be. So Alina and her team put this together using the DRM technology we have out of video, using all of those pieces, like I mentioned, from wireless LAN controller, DHCP, our identity services engine, and link them together in a policy database. And what we're looking at here is access to sensitive data in an enterprise. And so what's interesting is you've got highly confidential data down to generalized data. And in that highly confidential area, we can see that, wait a minute, it's being accessed all over this campus, including in the cafe. And wait a minute, why is our financial data being looked at in the cafe? This seems interesting and potentially strange. And realize that until you have a linkage between the data object itself, the electronic asset, and the network, you can't see where stuff is being accessed and where it's being used. So why don't we try and fix this, Alina? So what we want to be able to do, and what Alina and the team have put together, is instead of a massively complex set of rules that generally have to be used in a network and asset system, in a hardcore whitelist, blacklist, filtering, identification, object relationship, is put this into a natural language. And what we mean by this is the finance team has access to the highly confidential data while they're on campus. But the problem is that includes the cafe. So let's turn that one off. And instead, let's add a new one where, why don't we just keep the financial data in the CFO office, as hopefully the CFO intended. But really what we're learning out of this is taking those multiple variables of the network, creating a new language associated with linking these together, identity, device, network, location, and application, in this easy-to-use language case, creating new verbs, and then we can now restrict that financial data directly to the CFO office. But you might say, this looks remarkably like what I just saw. And what Alina's going to show you is that we can see historically where this data was accessed by who, and by whom. And so she's slowly moving up the time from an hour ago to right now. You move it to right now, nobody's accessed the data, which is why it's empty. So, all right, somebody's going to go and access the data. They happen to be in their office. It's a CFO. Hey, that's all cool. The CFO can see financial data in the CFO office, but we just instantiated a rule that when they go to the cafe, that's going to be denied. And in fact, this is what we're showing. So what Alina and team have come up with is, again, linking together variables associated with the network with the electronic assets and their decryptability, using an SDN controller and a policy manager to associate those variables together. And then we have a full login history of who tried to access that piece. This sounds really obvious, but until Alina came along, nobody had invented it before. So thanks, Alina. Great job.
Great.
Jedi mind trick number 4. So what becomes interesting when you've got an SDN controller and you have a number of mobile devices is you have the ability now to understand the data that's coming from those sensors in the device. And the first setting I want to look at, pay no attention to the Porsche on the slide, is a transportation example, and I'll get to this data in just a second. In a trucking business, think about it this way. The contents of the rig, the actual material that's being transported, the person who owns that and is trying to move it is interested in that data. They're interested in the temperature if it's a refrigerated piece. The truck owner is interested in what is the weight of the truck, what is the wear of the tires, what is the current fuel usage, and what is the route that's being taken. Where is the traffic on this, on the road, and can we reroute them? In these particular cases, we use an SDN controller working on a passive listener to the onboard data system associated. It's passive only, and are able to and have built a software platform that allows those different pieces of sensor data to go to the different owners of that data. And again, this sounds really obvious. Well, of course the person who's sending the material wants to know its current status and where it's located, but they don't need to know the actual, they don't need to know the wear or the weight of the particular vehicle, as an example. And so as we built this out, we used open daylight and have worked with a number of transportation suppliers as well as service providers to be able to distribute this data in a complete software platform way to have it be programmed in a transportation case by case, depending on what's being trucked. In this example, now please pay attention to the car, what we're looking at is that same passive listening piece. Actually pay attention to the onboard diagnostics module inside the vehicle itself. And you can go up to DevNet right behind Game of Life and actually see the unit itself and drive a car in a game environment, which is representing and pushing out that data. And you're going to be able to see the impact of every aspect on that particular vehicle. Now, what's interesting is that we're also working with a number of auto manufacturers, because the challenge becomes, with all the data that's sent out of these particular vehicles, in some cases, the manufacturer needs to know, in some cases, the leasing agent needs to know, and in some cases, you want to know what is the wear of your tires. And yes, you can go out and look at them, but some of us sometimes don't pay attention often enough on these pieces to be able to understand all of these different elements. So towards this end, take a look at how SDN, programmatic networking, can work in a couple of different ways that we're looking. One is Alina's with respect to the asset protection, and the second is trucking and transport, and both of these are available to be seen upstairs. Thanks a ton, Bart. If you could just relax for a second. So what I want to be able to do is just summarize what we've chatted about, because I went really quickly, because all of this can be seen upstairs. We've reached the point in the industry now where applications in a platform like Cloud Foundry can interact with orchestration systems, where the top of ours is NSO from TLF, underneath that is OpenStack and Open Daylight, and below that is both physical and virtual devices, where we've just recently open sourced VPPE, and we now have programmatic interfaces across our portfolio. Moving over to a notion of a platform for data analytics, And you can see that upstairs with Nick and Trev and the team. And you saw some examples here of by being able to aggregate and correlate that data and provide natural language processing, we can correlate those events together and via a Kafka bus connect that directly up to the controller for a reactive network. And all of these pieces together have finally arrived in the industry such that we're not just talking about programmatic networking, we're not just talking about NFV and deploying services from that user interface in which provisioning those services was done by the end customer. And the end customer can understand what they're purchasing and seeing the activation of this. The enterprise IT professional can, again, operate their entire network. The product manager and a service provider actually now has the ability via model-driven services orchestration system to understand the state of their products to be able to be deployed. And then the field technician has access to that data to be able to go out and do their jobs. These are all the different facets that programmatic networking and reactive networking are bringing to the industry and that we're building here at Cisco. So Scott and everybody else, thank you very much for your time this afternoon. Go check out DevNet and all the things that I talked about because they're all right up there in much, much greater depth. So thank you very much.